Hello everybody and welcome back to Space Engineers. But today we are going to be looking at piston based engines. Because what's a better way of inflicting clang upon myself than messing with rotors, pistons and physics? Yes, so without further ado, let's get straight on to today's video. Okay, so for today's video, like I say, we're going to be looking at piston engines, which basically means we're going to be looking at crankshafts. And if you don't know what a crankshaft is, it's basically the part in most engine, or in almost every single engine, which is where all of your pistons are connected to, and as that spin, or when the pistons put force into it, that spins, and that sort of spins your, transmission and spins your wheels in the end. Basically, that's about as easy as I can make it. So I tried to make that in Space Engineers. So the first attempt I made was this one. So this is a nice little. This is technically inaccurate, but it's a four piston engine. And I was like, oh, this could be easy. You have your first main rotor, which goes into a pair rotor, so this can spin when you have your pistons down here, and these can be on 3 hinges, so they can, like, as they're spinning, moves backwards and forward. They'll technically move in this line around there. And that makes sense. You go down, you got each one of these 4. First thing wrong with this, you can't have a piston in a mid-state going, extending and contracting more, so this whole thing about having in 4 different positions would be basically impossible. You really need to have them either on the extended point or on the retracted point, and stick just to those, so you'd have like 2 extended, 1 and 2 retracted, or something like that. The second main thing wrong with this is, sure, if you supported this on the other side, you could have another connector here. That's not your biggest problem. So obviously, let's say if I increase the speed, don't worry about the shakeage. Makes sense, yeah. Looks good, and then you realize that if you made this a free bearing, yeah, the whole thing just has absolutely no structural integrity. Why? Well, hello, what's it doing? Because this is not quite how a crankshaft works. Now, I'm going to show a picture on the screen now and trying to explain it a little bit in more detail. But essentially, you can see the crankshaft has these points between where each of the pistons connect to. And connecting to each point is actually a solid metal rod. And then on the outside of that, you have a little bearing, which is then what connects to the piston. So the crankshaft is one solid piece. And then it has an outer little shield, which is then what connects to the piston and all that kind of thing. And that makes sense. And then you realise that it's pretty much impossible to do in Space Engineers without everything exploding. So I moved on to my next best thing. So the next thing was me starting to experiment with my favourite broken thing in this game, and that is none other than connecting piston heads to wheels, and making these parts have no collision, at least on the grid that they are connected to. So, in other words, I could technically pass a block through, another block, and it wouldn't have a collision. Now, the only problem is it doesn't quite work because the actual piston, or actual rotor head here, hasn't got a collision, which means it would never pass through this. Otherwise it would technically work. So my idea was maybe, have a crankshaft and have a supporting bar across each of the tops, and then you could have the piston, or the other pistons connected to this block here, and it would spin, it would make sense, everything would be supported, and it would work. Problem is, it doesn't actually rotate. It does make an interesting clang drive. But yeah, so there's another rotor here, that's turned off, got no rotor lock and no RPMs. Problem is it just doesn't spin. But it does interestingly spin this, which Very interesting. I wonder if what if I put more force under it? What if I push it the other way? Nothing. Yeah, I don't know. This was basically a failed idea. And the main reason for this is due to the fact that my little contraption here, this is just half of it. The full thing's here, you know, you've got 2 points. Main reason it doesn't make sense is because you can see here, this is where your rotor head is connecting to your block inside of this wheel suspension. But this puts the actual block pretty much halfway between 2 blocks of the grid that this is attached to. Which is a little bit annoying, but it sort of works, but it doesn't work. Because that means you can't have like a block here, it'd be rubbing. It just doesn't make sense. Doesn't make sense at all. So this is where I was like, okay, so if that doesn't make sense, let's try and make something that does make sense. So this is my new crankshaft, and as you can see, it's I don't want to call it a two-phase because it's not a two-phase, but it's basically you've got 2 pistons where they're fully retracted, and 2 pistons where they're fully extended. And then these would retract, these would extend, and you'd get a spinning motion. And as you can see, the absolutely appalling, terrible looking piston through blocks without anything happening, you get to see here. And that basically means that, so how this works is this wheel, or wheel suspension, creates a subgrid. Now this subgrid isn't technically coded in the game. The game says this technically isn't possible, so why would it create a collision? Which basically means as long as you're connected to this subgrid, you have no collision with the grid that the wheel is sat on. You have collisions with everything else, but just not this one. Which means this block and this piston does not have a collision. It means this one has a collision, and this and all this has a collision, and sure, but this piston doesn't have a collision, which allows you to do this. And what does that allow you to do? It allows you to have a solid crankshaft which can pass through and actually spin and work. You can see this is from where we started, we're actually getting somewhere. So I made another one of these just to get somewhere where we can actually work. So right here, this is a basic working one. So we've added a bit of a flywheel, which a flywheel is basically just weight to keep momentum going. And if I remember how to do this, I believe you turn the rotor off, and then you click, and click. This is a very manual one. You can see we get a rotational force. Actually, the whole fact that these are on wheels help it to be a bit more smooth. And it spins nicely. For the most part, there you go. Perfect. And if I just pause that. There we go. It's doing a piece of its own thing. At this stage, I also, from this iteration to this one, I also learnt one very important thing, which I didn't notice, and you probably didn't notice on the picture I actually showed of the flywheel, or the crankshaft either. And that is, on a crankshaft, the actual connection points, sure they're away from the center, but they're also off-axis. So as you can see here, one of mine is off-center by a block, and the other one is off-center by another block. And that, I'm guessing, is just used so you have a starting force which keeps it propelled in a certain motion. You can see when this is at a stationary point, it's at an angle. Which means forever, when I press this button, it will always rotate in one direction. You see? It stops at this angle. It goes round. And it stops at that angle. And once you start getting it spinning, the flywheel helps and it works more. So you can sort of see it working in a manual way. So what about it working, you know, automatically? And that is where I started to mess about with sensors. I was messing about with all sorts, trying to get like, you know what, I'll just show it, right? So the way this works is the sensors are currently off. You send the pistons on and then you turn on the sensors and it should just continually spin. Basically, anytime the sensor detects this yellow block, it reverses the pistons. But there's a problem you see right there. Sometimes it doesn't quite get far enough before it gets hit by the sensor, and it doesn't actually spin in the right way. For the most part, it recovers. You can see. But you can see the amount of clang happening on these pistons are quite insane. I've never disconnected it from a solid base. These are all connected via rotors under here, so they're quite solid. I don't know what would happen if I actually disconnected it. We might try right at the end of the video, so stay tuned for that. But for the most part, it works, right? Now, this is working at a quite slow speed, and the way you turn it off is literally just turn off the sensors, and it will just stop at its next bit. So you may be asking, but Quantum, or Chief, or whatever you want to call me, how fast can it go? And the answer is about, 2 meters per second, like, on one. Added a bit bigger flywheel, tried to tune it a little bit better, and it works in the exact same way. But it's not as efficient, it gets a little bit confused, as you can see right there. But it does spin a lot faster. Like, you can definitely see you're getting a good bit of rotational force on the output. It's not consistent, and it's not necessarily saying the same way, but it is spinning this block. There are certain things I can try and do to make it a little bit more efficient, or spin constantly in the same way, and that would be moving this block one block further. And the reason this is sort of like getting slower when it extends is because all of these are going in 2 cycles rather than it being like 4-stroke or like having multiple phases to it. But I got it to a point where it worked, and bear in mind all of this took me a couple of hours at least to even just get it to work. A bigger flywheel helps, because there's more mass just naturally wanting to spin it around in a certain direction. But yeah, it's an interesting concept. All thanks to use of, you can see, all of these designs allow you to basically just put blocks through these. I can't see another way of doing it in small grid. The only other way I see doing this is using a large grid and using the railings. As you remember. The 2-part railings, these ones have a block in the middle, like a gap in the middle where you could technically, I don't know, maybe fit like a block through. I haven't experimented because this is already big enough and it's a small grid, so putting it into large grid would just be absolutely insane. But then it begs the question, what's the point of even having a piston engine in the first place? All your wheels are powered naturally, you don't need a drive shaft or anything like that, you don't really need any movement. You have rotors if you need a spinning force. And if you really need a strong force, you could technically just have a rotor with blocks on it and some gyros. Gyros act as a force and spinning around you, which is basically a completely pointless thing. But if you want to see more of this kind of thing, like if you want to see me see how I can evolve this piston engine and maybe make it more efficient, maybe make it faster, all those good things, make sure you do subscribe to the channel and leave a comment to say that you do want to see more. But yeah, as I did say, I'm going to disconnect one of these when it's running just to see what it does. I am going to move it all the way over here, out of the way, just to make sure that nothing explodes, of which it probably will explode. So this is fully disconnected, just so you know, from the actual base. Oh, it's got a lot of clang. Beautiful. Oh, where's if I turn it on? I don't think we have a button anymore to turn it on. Um, don't worry, I can easily resolve that for... Oh, we have no battery. Ah. I can also fix that issue. And we'll just, you know, reverse these. And toggle these on. Oh, I see. This is just no longer connected to the actual base full stop. Okay, so this isn't going to run either way. Oh, well. Yeah, well, at least have a good title. Piston engine, more like Clang engine. And no, don't ask me to make a Clang engine using Clang drives. That is not happening. That is pretty much what I've created here. Yeah, that's how I'm going to end today's video. As you can tell, this is what progress I've made into trying to make a piston engine so far in Space Engineers. It's difficult for the pure fact Clang is so insanely strong, and things just don't always make sense. But like I say, if you do enjoy these videos, make sure you do subscribe to the channel. Helps me out absolutely immensely, and the fact is only 10% of my viewers are actually even subscribed to my channel, which means there's 90% of people who watch these videos don't subscribe, which is a little bit sad for me, you know. I'm trying to make good videos here and, you know, expand the channel, so if you are one of those people that are not subscribed and you've watched at least a couple of my videos, or maybe this is your first one, maybe check out a couple more and find out. Maybe you do want to subscribe. But anyway, my name has been Quantum Chief, and I'll see you all in the next video. Bye!